So today's lesson, 531, right? Today's lesson is all about interpreting graphs. It really is all about interpreting graphs. And we're going to put this word in there, functions, because most of our graphs will be functions, okay? All right. So we're going to be interpreting graphs or functions, right? So what I want to do is just get kind of a verbal description of what's going on. So if you took a look at this graph, you've got time in terms of minutes, right? And you've got rate. Now rate's going to be how fast, right? Rate's how fast, and here's the time. So if you look at this graph, what's one thing in this graph that you see? Vanessa, what do you see in this graph? Is there anything you see that you can tell me about the trip? We're going to take a road trip. So what's one thing, Vanessa, you see in this road trip? Okay, you're getting your car, right? You get in your car. So watch, you guys. I get in my car. So where would there be traffic? Where would there be traffic?
The time it took. Like where you're sitting there.
Maybe here. There might be. Well, what do you think about here? So you slow down, right? Okay. What do you think about this right here?
Probably pretty steady.
Yeah, we're not quite on the highway because we're not going 60, right? Right? Okay. Guys. Shh. So this might be the highway. You okay with that? What happens right here?
They made their destination.
Oh, maybe not. And then we go again, right? So
maybe they had to get gas.
Yeah, gas, a potty stop, or whatever. So if we were going to write a description of this, we'd say something like this. Here's my description. I want you to write it. Here, my description might be, I get up, I hop in my car, and then I speed up to get on to possibly, I don't know, maybe we're going down, maybe we're going up the Chumstick, okay?
Yeah.
So I speed up on the Chumstick, and then I have to slow down because maybe I'm hitting some traffic, right? So slow down a little bit, hit traffic. Then I speed back up right here. I'm probably on the highway, right? On the highway. Cruising along at about 6 miles an hour, but then Landon says, Dad, I go to the bathroom. Please, Dad, stop. So, okay, Landon. So then we slow down. We stop. 80 minutes into it, right? Landon's bathroom, and then we get going again. That's my description. Let's see if you guys can write yourself. Will you write yourself a little verbal description of what you just did? Okay? You guys, go ahead. Make your own just right here. Just right here. Make yourself a little road trip story, okay? Make yourself a little road trip story, okay? And you just have to be, you can do whatever you want as long as it fits the graph, right? Right? Could have been that maybe you were speeding right about here and you got pulled over. I don't know.
60 miles an hour.
Well, maybe you're on the maybe you're on the back roads, right?
And the freak's like you're such a crazy.
School zone, right?
Tell me when you're on the road.
Right.
It did almost.
Oh, I'm gonna do that.
Dude, how? He was coming up
Okay.
to Joe's and I was pulling in and he was trying to pull out and I was like,
This is 20 miles an hour. Maybe I got stuck behind a logging truck, maybe for a little bit, right? Couldn't pass, maybe, right?
He had a way bigger car than I did. I know your car now. Yeah, he's like, I know your car.
So let's just take a minute to make your own verbal description. Just write something that you think. Come on, Ethan.
Wow, thanks.
Give me a little description, Ethan. Give me a road trip. Okay? Give me a road trip. Good job.
Can I just say Wenatchee?
Sure, wherever you guys want, right?
Sonic.
So,
Sonic's like going to Sonic. You know what really? He does. He does. Did I tell you I'm working with him now? Oh yeah. There's churros out. Yeah. Or churros.
yeah. Great. Awesome. You got anything?
Churro or Charlie? Churro. I know, I was going to say. Charlie's gross.
You guys give me a little verbal description of what's going on. We're so lazy. Right. Use that pen, you muscle. Exercise those muscles, right? What would you call it?
I don't know. I think it's because it's not. I have pieces that won't fit. Like they're just I have it. Yeah, it's just like an inch too short to fit. I'm so ticklish. I'm not.
Right. Or maybe what's it?
I did it, Davies!
Maybe we stop here. Maybe we stop here at the rock, right? Oh, John, and John's talking about going up Blewett. So John's talking about, you take off and you go like through. You drive through Leavenworth right here, and then all of a sudden you hit traffic, right? Then you get on Blewett Highway. So then you get on Blewett Highway, cruise along, and then maybe you got to stop at the rock. Go to the rock, stop at the rock for something, go to the bathroom, get something to eat, and then off you go. Okay?
I said coffee stop.
I like coffee stop. Yeah.
It's a
Okay.
white girl.
There we got one. Okay, so let's check out number 2. Stacy runs 3 days a week. She keeps track of her times and laps. Okay, so we've got laps. Laps. How many laps and the time? So she runs 2 laps in 13. So I'll probably put a dot right about there. 2, 4, 6, 8, 10. So maybe a dot there, right? 4 at 16. Okay.
Like she runs 2 laps in 13 hours, she runs 4 laps in 16.
She'd run fast, huh? 16 minutes?
She did 2 other laps.
Right. I know. So then she gets 4 laps in 16, 12, 14, 16, 6 and 19, right? 8 and 22, right? And 10 and 25, right?
Pretty steady.
Yeah, it's pretty steady, right? Okay. So it's not exactly straight, but if we had to draw the line of best fit, it's what I call line of best fit. I might draw it something like right about here. Here's my line of best fit. Okay, you guys all right with that? Yeah. Did I miss one? Did I miss one? Okay, 2, there's 12, 14, 16, right there. Okay, actually, thank you. Thank you, Joseph. Okay, now, are we going to stop talking? So, all right, we've got a line. Is it a straight line? So what equation should we use if it's a straight line? What equation should we use if it's a straight line? Okay, how about y equals mx plus b? Okay, great. Okay, now we need to know something about the slope. All right, so we can get the slope by counting or by just looking at the numbers. All right, one way to look at the numbers is that as we go up 2 laps, we go 3 this way, 2 this way, we go 3 this way, 2 this way, we go up 3 this way, 2 this way, we go up 3 this way, okay? So our slope would be, we're going up 3 over 2, up 3 over 2, up 3. So one way to get our slope is from the chart, okay? So the slope would be 3 over 2, okay? The other way is to count it, right? Up 2, 3 over 1, 2, right? So it looks like it could be up 2, 3 over 1, 2. It looks like 1, 2, 3 over 2, 4. Now I could be off on this, couldn't I? But it would reduce to the same thing. Okay, so we've got my slope. What's my y-intercept? Sure looks like it's 10, doesn't it? Right? Doesn't y? So I could say, okay, maybe it's y equals 3/2 x plus 10. All right. Now, is that accurate? Is there a way to check if it's accurate? Can we use a formula? Can we use a formula? Sure, I'm going to use a formula to double check, see if it's accurate, okay? So I don't know, is this accurate? I'm not sure. So what if I use a formula? What if I use my y minus y1 equals m times x minus x1, okay? So what's my slope? Looks like it's 3 over 2, isn't it, right? And I could pick a y1 and next I could use a point, right? How's that point? I could go y minus 13 equals my 3/2 times my x minus 2. All right, and I'll stop for a second and let you catch up, okay? So is my answer right? Okay. Probably, but I'm just going to check my formula, okay? So I used a point, any point. I just use this one because it's the easiest point, right? Any point, right? So these are my x's and these are my y's, right? All right, so if I use my y minus y1, that's my 13, equals m, which is 3 over 2, x minus x2, which is 2. Okay, and if I simplify this, y minus 13 equals, I'm going to distribute, and I'll get 3/2 x minus 3, because 3/2 times 2 is 3. And if I add my 13, I do get 10. So it is accurate. Okay, good. Now, can you use that equation to get the next one? Sure. How are you going to use to run 20 laps? Okay, how are you going to use that equation for 20 laps? Plug in 20, right? For x or y? X. Correct. How do you know it's x? It says laps, right? It says laps, and laps has, that's my x and that's my y. Josie's completely right, so let's plug in 20 for x. So go y equals 3/2 times 20 plus 10, right? So then half 20 is 10 times 3 is 30, so I go y equals a 30 plus 10, or we get in 40, and that would be 40 minutes, right? Now, one thing I would do, and you don't have to do this, but one thing I would do is I would have changed my equation to m equals 3/2 L plus 10. Why do I like those variables better? Why do I like those variables better? I don't x and y, m and l. Why m and l instead of x and y? Anna, why would I use m and l instead of x and y? Please tell me.
I have absolutely no idea.
You don't? What's this problem all about?
Laps. It's about laps.
Well, there you.
Maybe it won't be as confusing. I don't know.
Yes, very good answer.
Yeah.
Way to go on the spot, huh?
Yeah.
Yeah, I know. So m would be like minutes, right? And L would be laps, and it makes it easier, less confusing. Thanks, Anna. Nice job, okay? Whew. You covered nicely, didn't you? Okay, you ready to turn the page? There we go. Okay, now, what about this one? All right. We've got kind of a big problem, but we can do it. So let's go ahead and highlight all the important stuff. So whenever I do a story problem, I like to highlight the important stuff. Okay, there you go. What's important in this thing, okay? Okay, 26 trees are planted an acre, each about that many, okay? Okay. It decreases by 12, okay? Use the chart below to create the scatter plot of total oranges as a function of number of trees, okay? Total oranges, so I'm using this, so I'm using these two right there, right? Total oranges, number of trees. We don't really care about oranges per tree, do we? Right? It says I want oranges, total oranges, as a function of trees, okay? So let's try and put a scatter plot together on this one, okay? So, all right, let's go 26, that's 25, 26, 27, 28, 29, 30, 31, 32, 33, and I think that's all the further I have to go because I only got 32, right? So let's do a little scatter plot, see what happens. So 26, right? 26 is here. I got a 14,000. 14,000. So that's 14. That's 15. That's 16. So 14,000, almost 15,000, right? So a 26 and just about there. Okay. 27, about 15. So a little bit over 15.2. Let's see, that's 15.2, 4, 6. No, it's not exactly. It's 250, 500, 750. Okay, there we go. And 27 and 2 is maybe, I'm guesstimating right about there. 28 and about 15,400, maybe right about there. 29 and 15,600. 30 and 15,800. Oh gosh, that's up here. 31 and almost 16. About there. 32 and about 16.1. Okay. Now it looks pretty straight, doesn't it? It does. It looks pretty straight. It looks almost linear to me. Okay, but I'll let you catch up. There's my scatter plot. It looks pretty linear to me. It doesn't look quadratic, but they're going to say it is quadratic, okay? So what happens is if it is quadratic, maybe the curvature curves much later. Does that make sense? We only let's say quadratic. So, wow, quadratic. Let's see, that's going to be y equals some ax squared plus bx plus c. And we've done all this, haven't we, right? We've done all this. Now, Teague, you passed out a bunch of calculators, right? But who does not have a calculator, okay? Who doesn't have a calculator? Raise your hand.
Mr. Davies, my calculator is like black.
Okay. I can maybe turn it. You guys mind sharing? You guys mind sharing?
Okay, then continue, Sarah.
Hello?
But Aaron, what else do you guys have besides burgers?
That means he's
You should get like an appetizer or something. I don't like meatballs. I know, I'm weird. I don't like meatballs.
We got 2 more left. You guys got it. Who has got one? Now, anybody else? Okay, I got one more left. Anybody have one? Okay, good. Now, so let's go back into stat. Remember doing this? Let's go back into stat. Okay. Remember I doing this before? So we're going to stat. Remember where my stat button is?
Oh, God.
Remember doing stat? Push right there, stat. Push stat.
Now what?
Right? So I push stat. And then we're going to go to edit, because I need to put some numbers in, right?
And you
Enter, right? How am I doing? I want to go slowly. We've done this before. That's the good news. I know, we can clear. Edit, right? Now mine are clear. If yours is not clear, you highlight the list. Push clear down arrow, right? You guys remember doing that? Okay?
Wait, how do you clear it?
Yeah, highlight your arrow. Go up, so it's highlighted on your arrow. Push clear, so go all the way up. Clear.
Oh.
You got it? Okay, good. Okay, yeah. Ava, you like using the calculus, right? So this is a good lesson for you, right? You do well on the calculus. Okay, so now we got to put in, I got to enter some data, okay? So I'm going to enter some data. So I'm going to enter data. And I'm going to do list 1, list 2, right? List 1.
we do oranges per tree.
So we'll do trees and oranges. No, we're not going to do oranges per tree. Okay. Okay, so then we're going to go and put in 26, 27, right? 28, 29, 30, 31, 32. How am I doing? Okay, good so far, right? And then list 2. Okay, we've done this. That's the nice thing about this. I go 14,976, 15,228, right? 15,456, right? 15,660, 15,840, right? 15,996, 16,128, right? Okay, I'll wait for everybody, okay? I'll wait for you to get it all in. And then we're going to give the next set of directions, okay? Enter data. L1, list 1, list 2, right?
Yeah, see, mine's not on the
Okay, wait, so what do you do? Do you put all the numbers in?
Okay, once you get all the numbers in, you guys there? Push stat again. Okay, okay. So push stat again. So you got all your numbers in, right? Push stat again, right? Now when you go to stat, you've got some options. Edit, calculate, test. Well, let's calculate. Let's calculate an answer, right? We want to get an answer. Let's go to calculate. So we're going to shift it over to calculate. So we're going to go to calc for calculate, okay? And now we've got several choices, but which one do we want to use? Right, we're looking for quadratic.
Yeah.
So let's use number 5, which is the quad reg, right? Let's use number 5. So we're gonna go 5. We're gonna go 5, which is the quad reg. Okay, so we. Yeah. You guys remember how to do this? Quad reg, right? Now I gotta get list 1 because that's where my numbers are. So second list 1, comma. Don't forget your comma. And then list 2. Okay. Don't forget your comma. So we're gonna go L1, comma. Don't forget your comma. L2. So who needs help real quick?
Can you just scoot over a second?
Okay, everybody see it? Right? Yeah. Okay.
I don't even know what.
Y'all help me. Oh, look at that phone. I'm gonna have to take that. I'll give it back to you later, okay? Okay, you're ready to go. Good. Good.
Where's the
Okay.
phone?
You're ahead of me, right? Okay, you're ahead. Yeah, those.
Oh, do you hear my back?
It is amazing. Oh,
No. Like, I'm not even kidding. She goes up like 6,000. I'm like, stupid. It's Aaron, I knew you were kidding.
There was like,
Because like, you Snapchats me and
she's like, oh yeah,
she was like, he'll grow up somebody else. I was like,
really? Okay. All right, you guys ready?
okay. So many guys.
All right, Carlos, at the end of the period, right? Okay, so then I'm just going to go enter. Wow, that's amazingly nice numbers compared to. So what's my answer? I need this. Okay, watch. So I'm going to go y equals a negative 12x squared plus 888x plus 0, okay? Now I'm going to change some things. Plus 0, you don't need the 0, right? You don't need it. So I'm going to go t. No, I'm going to go oranges. I'm going to go O equals. I better make it oranges. That's an O. Let's see, what can I use for oranges? Total oranges? Total. I'll go total. Total equals negative 12 t squared plus 888 t, okay? And why would I use big T and little t? Probably has nothing to do with X and Y's, does it?
Nope.
Has to do with trees and total produce, right? Total oranges, okay? Now, almost done. Find the maximum number of trees. Find the maximum number of trees to plant and the total number of trees of oranges, okay? The maximum. There actually won't be a maximum because it's not. Oh, it is negative. There is. There will be a maximum. Anybody remember how to find the maximum? Anybody at all?
Why is there a plus?
Okay. Yes, you can graph it, but I like the other way better. Let's find the vertex. Yes. Anna, did you say vertex? No, who said vertex back there? Was it Sarah? You did say vertex? Nice. So, how do you find the vertex? Does anybody remember how to find the vertex? Nice. It's negative b over 2a. Nice. That's right. See, we've learned a lot, haven't we? So the vertex is going to be negative b over 2a, right? So I'm going to go a negative 888 divided by 2 times negative 12, right? Let's see what I get for an answer. I'm going to go 888 divided by 24. I get 37.
Negative 24.
Well, I just canceled both negatives because I was, So I got 37 trees, right? I need 37 trees, right? What would our maximum be? How do I find out? So I'm going to plant 37 trees, and what would the maximum be? How can I find that? Plug it in. So I'm going to go, yes, I'll wait for you. So good. Maximum, I use my negative b over 2a. See, all of this is coming back. You guys have done this. You can do this, right?
Will you do that part again?
Yeah, I sure will. Sure. So what I did, Avi, to help me to make this easier, okay, you're with me on the formula, right? So here's my b, right? And here's my 2a, right? And so for me, because I get messed up with calculus sometimes, I just went positive 888 divided by 24. So what I did, I canceled the negatives and I made 24. That way I'm not going to mess up my calculator, right?
Why is the 888 there?
That's B, right? Great question. That's your B. There's your A, and there's your B. Good question. Really good question, okay?
How did you find that?
You got it on your calculator, right? Remember that was our, right? That's our formula? Yeah. Okay, now, plug it in. You guys said plug it in. So let me plug it in. I'm going to go T equals, right? Negative 12 times 37 squared plus 888 times 37. Let's see what our max is. So use my calculator. find our total. So I'm going to go negative 12 times 37 squared plus 888 times 37. And I get an answer of 16,428 oranges. How's that? Okay, so nothing new, is it? It's stuff we've done before. The only difference is, in this chapter, we're going to look at all the graphs that we've done before.